You don't remember how to simplify the square root, Liliana? Mia? We need to find factors. So let's go back to Liliana. Can you tell me two numbers that multiply to 24? 2 and 12. Yep. And we keep going until we have primes. Okay, so 2 is a prime, so we need to keep breaking down until everything's a prime factor. Angelina, how does 12 break down? Good, 4 and 3. So 3 was a prime, and 4, I think we all know 2 and 2. So we'll just hurry through that step. So on your quiz that I graded last week, lots of you, why is the board not working? Lots of you just left, it's okay, frozen. Lots of you just left your answer like this. This is not the answer. Actually, this would never be the answer for anything we've done. It's a partial step, but you're not done. So please don't leave your answers with just the factors circled. Give us a sec to register. Let's see if it wants to work now. Oh, lovely. Okay. Can we write? We can write. So when we're simplifying, we get all these circled factors, 2, 2, 2, and 3. What do we do with them? John, what do we do with them? Jonathan? Do you go by Jonathan? Okay, Jonathan. Yeah, yep. We put them all underneath the square root. And, Justice, what do we do when they're all under the square root? All of the 2's together? How many 2's together? 2, a pair of 2's. This board, wow, something's really going on with the board. You look for pairs, and then we're allowed to pull them out. So a 2 pulls out, and who can tell me what we get underneath? Jackson? Which is, okay, so we do simplify that back together since these 2 don't match. And this is our answer when it's simplified. So if they got this answer, that's 5 points. So please don't stop after the tree. You need to keep going. Jackson? No, because it's not simplified. They have to put them back together. Okay, since I can't see the board, is it 36? Is that the number? Yeah. And it said find the prime factorization. Okay, so we have to find the prime factorization. What steps would we start with? Is it law? Law, what would we do first? Like this? Okay. So we start the tree again. So both of these, when it says simplify in the directions, you do the factor tree. When it says find the prime factorization, you do the factor tree. That's the same first step. So 6 and 6. Okay, and Kelsey, and she wrote on her paper, bugs you when people forget the T, right? So am I saying it right? Kelsey? Okay. Kelsey, how do the 2 6's break down? 2 and 3. Okay, so once again, this is the end of our tree, and that's not enough. You don't stop. You have to keep going. But these are different directions. It says prime factorization. For raise of hand, who thinks that they know how to write this in prime factorization? Okay, Victor.
Like the final answer.
Mm-hmm.
Times 3.
Madison, what do you think? Yeah, good. So it should be least to greatest with all the primes. You don't write the 6's. You write the primes that are circled. We have 2 2's, so that's why it's 2 squared. Times, and don't forget the times. You don't put a comma. Some people were putting commas on their quizzes. It's the times. 3 squared because there were 2 3's, and that's prime factorization. Simplifying, you're trying to pull anything out of the square root. Prime factorization, you should see all the factors as primes listed least to greatest with an exponent if there are multiples. Okay, so 5 points for each one with a total of 10 points. Please put their score on their paper. Okay, on our agenda today, we need to pull out our power rules and negative exponents assignment. Okay, so there are only 12 problems. I think we did probably one in class together. Are there any questions on this worksheet? Email. Number 11. Not all of them.
Can't help on all of them.
I'm not going to do all of them. That's why I only gave you 12, because I didn't want to cause too much torture. Okay. Great, so we're doing number 11. So everyone should either be checking your work and your answer, or you should be writing work and answer and participating with us. Have a product rule in the denominator. No, because u and v are different, right? They are being multiplied, but they're different, so they're not like terms. Do we have a product rule in the numerator? Yes. Now, normally there's only one power rule in the numerator. So doing the product rule, remember the wrap? It says when dealing with these exponents and the what?
Subtract.
Nope, that's not the next line. When dealing with these exponents and the base is the same. Inside the parentheses, this is the base for the -1. Inside these parentheses, this is the base for the 2. Are bases, the parentheses, the same? No. So we can't actually do the product rule right now because the bases are not the same. We have a huge problem having two power rules. So I'm going to suggest that we get rid of these parentheses first. So let's do the power rules. What does this -1 tell us? What does the -1 tell us? Moroni? Okay. Remember we wrote a 3-word phrase with this exponent on our notes. If you don't have your notes out and you don't know, pull them out. And Isaiah? The number of copies. So this tells us we have -1 copies. Does that make sense logically to have -1 copies? I go to the copy machine and I push, I want -1 copies. Does that make sense? No, it doesn't, because it's negative. How can we make this positive so it did make sense? We learned negative exponents last time. How do we change negative exponents to positives? Nia? That's exactly what we do. All of it together. It's moved down to the denominator and it will become positive. Okay, so this 2v to -1 all squared doesn't move. It stays because it's already positive. But this section where I circled, we're going to move it down to the denominator, and that changes the -1 to a positive 1. And we still have times u to the -4, v to the 0. Okay, now the power rule would be a lot simpler because, let's get a light color, because this tells us there's one copy. So it's here. We don't have to actually rewrite it. If it makes it easier for you, you can, oh, it's going to erase all of it. Do it? No. We could erase these parentheses because it is our one copy. If it makes it easier for you to see. Okay, Jerice. Did I say your name right? Okay. Is there another power rule? Kind of. The power rule is when there's parentheses with an exponent outside. Is there another power rule, Therese? Do you see parentheses with an exponent? Do you see parentheses? We'll start there. Yeah, right here, right? And what's the exponent, Therese? The 2. So this tells us the number of copies. It means we have 2 copies. So we're going to write down our 2 copies. 2v to the first, so negative first, times 2v to the negative first. The copy part, you understand that? And actually, I'm going to save myself some time. Look at the denominator. How could I save myself some time in the denominator? Zach? Yeah, power of 0. We don't need those. Because anything to the 0 power is 1, and timesing by 1 doesn't do anything. So let's just get rid of it. So I have 2v cubed times u to the negative 4th. Already looking a lot simpler. Raise your hand if you have any questions. Yes, Nia? Yeah, I'd probably just do that one at the end because I'd probably want to combine these first, but eventually we're going to have to solve that, yeah. Okay, so look at the rules, product, quotient, power rule's gone. Which rule should we do first? Should we do quotient rule, dividing, or should we take care of product rule? Product. Point, is it the numerator or the denominator that has the product rule we need to take care of? Is it the numerator or the denominator? No, I said point. So, point. Numerator's up, denominator's down. Which one? They can't be both. It's one of them. Which one? Has like terms that we need to combine using the product rule. Yes, thank you. The numerator. Okay, I think we went over this a lot last class. These big 2's have a name. Oh, I heard it in the back. It was a girl. Somewhere over there. Be brave. Oh, I heard it again. Who's saying it? Be brave. Nemo, is it you? Okay, everyone let's just shout out at the same time so we're not so scared. 3, 2, 1.
I don't know.
I don't know. Coefficients. Now you know. Whoever said I don't know. It's coefficients because these are not exponents. So thank you for not saying exponent. So our little tricks about multiply, add, doesn't apply to coefficients. That applies to exponents only. So we do whatever operations in between them. What operation is between these parentheses? Ooh, I heard 2 things. I heard times and add. It is times. Times is the multiplication is the only one allowed to be invisible. So 2 times 2 gives us 4. And these v's are also like terms. I hope everyone's writing with us, if not checking your work if you've actually done this problem. When dealing with these exponents, the base is the same. The 2 v's are the bases. What do we do with the exponents? Multiply, add. Multiply, add. So negative 1 plus negative 1 is negative 2. And then I'm just going to copy the denominator because we don't have to do the product rule down there. Okay? I know, it always does. It always does. Okay, let's see. Someone I don't talk to very often. Spencer. Product rule is done. So what do we have left to do? Well, which one is present? Only one of them's in the problem. Do you see the quotient rule? You can close the door in the back, please. Quotient rule or the power rule? So power rule has parentheses in an exponent. Do you see parentheses? No. So it's not power, which means it has to be quotient. Okay, so that's our division. Okay, let's try this again. These two numbers, shout it out. 3, 2, 1 are called coefficients. So we do whatever's between them. 4 divided by 2. Show me what's that answer. 4 divided by 2. You'd be surprised some of the answers I get, so I really have to check. 4 divided by 2, what's the answer? 2. Thank you. Okay, here we have like terms, and the bases are the same. When we divide, then we have to subtract. Okay, this is tricky. Raise your hand when you know it. Negative 2 minus 3. It's tricky. Negative 2 minus 3. Raise your hand when you know it. Negative 2 minus 3. Okay, people, don't snap at me. I'm going for people, I'm trying to learn names. Ariana, what'd you get? Good. If you're thinking 1, you're trying to add, okay? Negative 2 minus 3 is negative 5, like she said. Good job. Now, here's a common mistake. This U doesn't have a U on top, but where is it? It's alone where?
Denominator.
In the denominator, so it has to stay there. And it doesn't have anything to combine with, so it's staying there for now. We are not done. We're close, but we're not done. Victor, why are we not done?
Because we forgot to simplify. I don't know.
Be more specific.
I don't know.
Okay, Brayden, what do you think? Why are we not done? This was called power rules, and
Negative. Oh, they have to be positive.
they have to be positive. Okay? They have to be positive. Let's go to Cassidy. How do I make this v to the negative 5th positive? Good. And notice how I circle it. Okay, the v goes with it, but the 2 doesn't. The 2 is positive. It's a positive 1. And the u, let's try Victor again. Where does the u to the negative 4th go? Up. Okay? Up. So they're going to switch places. 2u to the positive 4 over v to the positive 5. Whew, Nemo, that was a really good question to ask, because that was long and complicated. The first notes we did this year. Who has it? Because half of you already have this filled out. Victor.
Is it prime factorization instead of prime radicals?
Yes, it was. So prime factorization slash simplifying radicals. Now on those notes, you need to give them the page number. It would be page 1. Okay, some of the page numbers might be slightly different than what your neighbor has, because some of you might use 2 pages for one set of notes. So make sure you're looking at your notes and getting them in order. If it is only 1 page, just put 1 page. If it's 1 through 2, put 1 through 2. After prime factorization, who else has already filled this out? You put the page number in the bottom right corner. Okay, Victor, keep going. What's the next one?
Adding, subtracting, and multiplying.
Okay, adding, subtracting, multiplying, radicals. Now this might be one that you have 2 pages on, so you might want to say like 2 through 3. You actually have to look at your notes and see, did I only use 1 piece of paper or did I use 2 pieces of paper? And in the bottom right-hand corner of all your notes, you need to put the page number. Okay, if you did not have your binder today, I will have this available for you to look at, because we're not going to go step by step again in class over how to fill out your table of contents. Okay, after adding, subtracting, multiplying radicals, Victor, what's next?
Math, product, quotient, zero, right?
Math. Well, we didn't say math.
Product,
Yeah, that sounds better. Product, quotient, and 0 rules of exponents. Okay, you'll need to find those notes and put a page number. If you happen to have been absent, you still need it, so insert a blank page and make sure you either go get them from the neighbor or go to my website, msgraysmath.weebly.com, which there's also a link on Canvas to my website. You do still need the notes. And they should have the essential questions, because that's what we've been working on this unit, was the essential question. Okay, after product was our newest one, wasn't it? Power rules and negative exponents. Power rules and negative exponents. Wasn't there supposed to be a wrap in here too? And then the exponents wrap. That blue paper, you need that. And also I gave you this white paper with all the properties of exponents. Let's have Brianna come up and get hers. Now here, I give it to you. This one, all the properties of exponents on one page. You want these all organized, ready for your test. I'm going to give you the exponents wrap as well. Because there will be a magic minute on the test where you can use these, but you only get 1 minute, 60 seconds, so you want to be able to access them quickly. Okay, properties of exponents. That white page with all of them together of exponents. And you do actually need to write the page number on your notes in the bottom right-hand corner so that you go, oh, I need to remember the power rule. And you go, power rule, what page? 5. And then you flip over to page 5. And today's is exponents and radicals, so might as well add that in. Exponents and radicals. All these things will be on the test. Beginning of next week, we will review next class, and then beginning of next week, we will have the test. Okay, and that's as far as we're at. So make sure yours is updated, put them in order, and put them inside your binders. If you are done, pull out a piece of paper for today's notes, which will be called exponents and radicals. And get your notes set up if you are done with the table of contents. You need name, date, and period. You need to look at the board and read the content objective and try to think of an essential question for us. Justice, is this yours?
Yeah.
Yep. Yep, that has to be brought every day. You're asking about the workbook, right, Morone? Yes.
What level does that question have?
In the level 2, you need to compare and contrast. Why question? Yes. Our notes today. Exponents and radicals. We need an essential question. Okay, let's have, where's my seating chart? It's under this. Jeremy, can you see that brown marker all the way over there? Can you read the essential question for us, loud and nice and loud? Oh, hold on, sorry. Students will be able to. Can you everyone pay attention? Okay, go ahead.
Digital solutions for irrational exponential expression, radical form.
And vice versa. Okay. Rational exponential expression into radical form and vice versa, which means and the other way around. So what's an essential question we can come up with that we don't know yet, so we should be able to answer by the end of class? There's about 35 of you, 34 of you out there. 34 brains should be churning. What's an essential question we can ask about converting rational exponential expressions to radical forms and vice versa? Yeah? Okay. We could ask that. That's a level 1. Can we make it a little bit deeper? Not just ask the steps, because that's just regurgitating information. Can we change that a little bit to involve a little more thinking? Yes? Okay. What's the difference? Because that's a compare and a contrast. What is the difference between a rational exponential expression and a radical expression? Is that what you're asking? Sure. Okay. What is the difference? Actually, let's put similarities and differences because they do have a similarity. So that would be what are, proper English, what are the differences? Between rational exponential expressions and radical expressions. I think adding in Mia's would also be beneficial. What are the steps to switch back and forth would be beneficial. What are the steps to switch back and forth? Huh? What are the steps? Well, the first one's a level 2, the second one's a level 1. It just looks 3. Okay. But, yeah, not technically. Okay, after you have that written down, let's draw our column. And I'm thinking we're actually not going to work on the column until after the first test. So we're just easing you into the Cornell notes. But draw it for practice. In our next unit, we'll start working on the column. Ooh, that is crooked. It's better. I'll move it back up to the question in just a sec. Okay. Good. Let's start with a radical expression. A radical expression, well, what's that? What does radical mean? Awesome. Okay, in the 80s, yes, radical meant awesome. You actually had a radical on your startup quiz. Does anyone know what a radical was on the startup quiz?
Oh,
The thing. This has a name. The square root sign is one radical. So they look like the square root signs. Okay, so the directions are, what is the simplified form? Is the simplified form? Question mark. Okay, so example 1, we're going to write the radical expression. So it has a square root sign, but this one looks a little bit different. So make sure your square root sign has this little lip. Otherwise, it looks like a division. If you just draw it like this, that's division. It's different. Okay, so division, don't do that one. Make sure there's this little lip. Yes? Yeah. The 3 goes on top of that lip. I know, it looks a little different, right? Raise your hand if you can tell me what looks different about this than one we had on our startup. Ariana? Yeah, okay. So we have this random floating number, small number on the lip. Okay, this number is called the index. So if you say the index number is 3, that's that number. The 125 is called the radicand. And the square root looking sign itself is called the radical. Okay, so vocabulary. Now with a square root, like the square root of 49 is, someone I haven't called on today. Amina, what's the square root of 49? 7. For our purposes today, we're just dealing with positives, because you could have a negative 7 as well. So, 7. Because 7 times 7 is 49, right? So when you take the square root, how many 7s did it take? 2. And we actually use the word square for a reason. When you find the area of a figure, so the area of, say, this triangle, two-dimensional triangle, and you say that the area is, I'm just making up a number, 37 inches. What comes after the inch?
Yeah.
Squared. Squared. Okay, so the 2 represents the word squared. So with square roots, you need a pair of 2. This is not a square root. This is a cubed root. Oh, dun dun dun. What if this was no longer a triangle, but it was, I don't know if I can draw this. Can you see that? I drew it really sloppily. It's a triangular prism in 3 dimensions. If I take this away, it might help. Wow, okay, I'm going to start over. Can you see that now? It's like an army tent. Here's the tent door right there.
Okay.
Has everyone signed this paper? Now, if we don't find the area of 2-dimensional objects, what do we find? Or of 3-dimensional objects, excuse me. The volume. So if we find the volume, and say the volume was, I don't know, 103 feet cubed. The 3 represents the word cube. So it's in 3 dimensions. So this is why we call it the cubed root. The 3 represents cubed root. So we no longer find pairs of numbers to equal 49. This instance, we'd find a triple that equals 125. So we have to think what number times itself 3 times equals, oh, Zach knows. What number times itself 3 times equals 125? Zach, what do you think? 5 times 5 is 25. Times 5 is, 4 of them make 100. One more would make 125. So that's it. Good job, Zach. So we're going to write out what Zach discovered. 5 times 5 times 5 is equivalent to 125, which means, like we did before with square roots, except for we don't find a pair, we circle triples. And pull it out, just like we've done before. Has to be triple, though, because it says triple. It says cube root. Which means everything pulls out, and our answer is, Victor?
5.
5. Is that what your question is?
Yeah. If there's like a different, is it always going to be a 3 that's on top of the little?
Nope. We're going to do another one. Be ready.
No.
Okay, let's try a 4th root. Example 2. And by the way, this was the, never mind. Backtrack that idea. Okay, 4th root of 16. So we need, and it has to be the same number multiplied. One number times itself 4 times equals 16. 4 times 4? times 4, something, times 4, something large. So it has to be 4 times, not just 2. So 2 times 2 is, times 2 is, times 2 is, there you go. So here's a hint. Generally, these numbers are small because by multiplying, they get big really fast. Now, when we don't find a pair for the 4th root, we find 4. So they all have, if there was a 5th one for some odd reason, only 4 pull out. And here, everything pulls out, so our answer is 2. Okay, thank you. Olivia, make sure you have a piece of paper for the notes that just started. Okay, raise your hand if you have any questions about that.
We should draw that in the
4th root?
Yeah.
I can't draw that. I don't think I could. I don't know. 4th root, well, we're going to, the next question might answer that, a little bit of why I'm not going to draw that. Because let's now do what our question said and go back and forth between a rational, excuse me, this is radical. They both start with an R, so I get confused. The radical expression, which is this, and we're going to turn it into rational. Does anyone know what a rational exponential expression? It's going to be an exponent that looks like a, what does rational mean?
fraction.
Exponent, that's a fraction, exactly. So, we're going to convert into rational exponential form. Example 3. Convert into rational exponential form. Let's just start with the basic one, the square root, so we can discover what it means. The square root of, we talked about 49 earlier. Okay, the square root of 49, we said was 7, because 7 times 7 was 49. Okay, this square root sign is actually an exponent. How many 7s did it take to become 49? 2. 7 times 7, 2. Okay, but is 7 squared equal to the square root of 49? Or is it only equal to 49 without the square root? 49 without the square root. So square roots actually create a fractional exponent where the 2, we know 7 squared makes 49. There's 2 of them. That's actually our denominator. So the square root is actually the exponent 1/2. Square root is actually the exponent 1/2. Okay, so let's look at one of the ones we did up here. Third root of 125, and we're going to change it to rational exponential form. So third root of 125 is actually 5. It took 5 times 5 times 5 to equal 125. We needed 3 of them. But this root sign here tells us the exponent is actually a fraction, which another word for that is rational. So what fraction would we get for 5? 5's exponent. If the square root gave us the fraction 1/2 because it took 2 7s to equal 49, oh, here we get some thinking going. Moroni, what do you think? 1/3 because it took 3, right? Okay, let's do the other one. Actually, let's do a harder one. No. Okay, I'm going to do a harder one.
So 5 and 1/3 is the answer.
If the directions said switch it to rational exponential form, yes. Then this would be your answer here. and here. You're just switching back and forth between forms. Let's try another one that's slightly more difficult. How about the third root of 8 squared? You can call it the cube root, which we actually call it more. Cube root versus the third root. The cube root of 8 squared. So, the cube root of 8 squared. Let's change this to rational exponential form. So let's have an exponent, that's a fraction. Any ideas? Ooh, we have an idea coming. Vanessa, what do you think? There are a couple ways you could do it. Not the factor trees, reverse the factor trees. Instead of finding the factors, find a multiple. You could do 8 squared. It might help some of you. What is 8 squared? 64, so that might help some of you to think about it. What's 4 times 4 times 4? Is it? I don't know. Try it out. Is it?
No, 16 times 4. Yeah. It is.
4 times 4 times 4?
Yeah.
16 times 4? Okay. So, it'd be 4 to what exponent?
Third.
1/3. Okay? However, for our purposes, I'm not going to accept this because it's actually a lot easier than that. You just keep the base 8 and raise it to, you got it, good job. Say it louder. 2/3. 2/3, okay? When we correct it, we'll be keeping the base and raising, remember the index, the number outside, it always becomes your denominator, always. So 8 to 2/3. And the last example, we're just going to go the opposite way. I'm going to start with the exponential form, and we're going to write the radical. Okay? So, what example are we on? 6. Convert into radical form. Example 6. Convert into radical form. So, 12a to the 2/3. Now remember, the radical form, the radical itself, is a fractional exponent. What piece here actually has a fractional exponent?
3, 2, or an 8.
The a. Does the 12 have a fractional exponent? No. If there was parentheses around 12a, then yes, it would, but there are not. So the 12 does not have a radical. The radical comes after the 12. Okay, you guys know sign language? A, B, C, D, E, F, G. Do you know A? Do you know 2? Do you know 3? Okay, because that's all we have left. Please show me with your fingers. What goes as the index? Please show me with your fingers. What goes as the index? Good. It's always the denominator. 3. Okay. Raise your hand if you can tell me what comes underneath the radical. Raise your hand. Oh, there's a hand. Janine. Okay. And there's something we haven't used. We have not used the squared. It stays with the a. Okay, so it's only the denominator that becomes your index.